Okay, so today is area of oblique triangles, and if you notice over here, it tells us that K equals area. So anytime you see that variable K, it just represents area. So in all three of these formulas, K represents the area of that triangle. Now, we will be given information in the problem, and from that information, you'll have to look and see how many sides are you given information for. Are you given information for one side of that triangle, for two sides of that triangle, or for all three of those sides of the triangle? So based on how many side lengths you're given in the problem will determine which one of these three formulas you need to use. So again, you don't have to memorize these formulas, but you do have to know how to use them. So if you are given one side in your information, you'll use this equation, K equals C squared times the sine of A, sine of B, divided by 2 times the sine of angle C. And we have a little note over here to the side that the C on top must match angle C in the bottom. So whatever side you're given, that has to be the same angle in the denominator of that formula. Now this is just one version of that formula, and this will be the only version you will be given. And there are two other versions, because instead of being given side C, I could have been given side A. And if I were given side A, then the formula would change to K equals A squared and then I need to multiply A squared by the sine of the other two angles. So if I have side A, the other two sides would be B and C. So this needs to be sine of angle B times the sine of angle C. And the angle in the denominator has to match your side. So if we have A squared, the denominator has to be 2 times the sine of angle A. So again, make sure your side in the numerator matches the angle in the denominator. So that's the second version of that formula. And the third version would be K equals. And we have A squared, we have C squared, so the final version would be the B squared version. So this would be B squared times the sine of A times the sine of C. And then the denominator would be 2 times the sine. And what angle has to be in the bottom? Angle B. This has to match. So side B, angle C, these have to match. So again, on the test Tuesday, you will only be given this formula written down here. These other two I created, you would have to be able to recreate that on your own. The next formula is if you are given two sides. So if we are given two sides, the formula for the area would be 1/2 times the product of the two sides times the sine of the third angle, which would be angle A. And again, that's just one version of that formula. The other version, we could have K equals 1/2. And what if they gave me angle B? What would be the other two sides? A and C. So this would be 1/2 A times C times sine of angle B. And one more version of that. What if they gave me angle C? What would be the other two sides? A and B. So 1/2 A times B times sine of angle C. So again, you will just be given this formula down here. You would have to be able to recreate the other two versions if you need it. And then the last formula is if you are given all three sides of the triangle. Then to calculate the area, you take the square root of this entire product of S times S minus A times S minus B times S minus C. And it tells us here that S stands for the what? Semi-perimeter. What does semi mean? Half. So I take the perimeter, so I add up all three sides, A, B, and C, and I cut it in half to get the semi-perimeter. So those are the three formulas, and you do not have to memorize them. So let's use those by looking at problem number 1. The instructions say to find the area of the following triangles. We'll round all these to the nearest 10. So number one, we're given B is 4.1 centimeters, angle A is 72 degrees, angle C is 41 degrees, 52 minutes. Now, to figure out which of those three formulas you need to use, look at the information given, and you have to ask yourself, how many sides do they give me? One side, two sides, or three sides? Yeah, just one side. So if you're given only one side, this would be the formula you would have to use. But which side were we given? B. So I need to use the one that has the B squared. So the formula we need to use would be K equals B squared times the sine of A times the sine of C divided by 2 times the sine of angle B. So again, this is formula based. Make sure you have the right formula. And once you have the correct formula, just substitute in the values. So what do I put for B? So 4.1 needs to be squared. Then we have the sine of A. What do I put? 72 degrees. For C, what do I put? 41 degrees, 52 minutes, and the denominator will have 2 times the sine. Do they give us angle B? No, but if I have two angles, I know that the third one should add to 180 degrees when I add all three together. So if I add 72 degrees and 41 degrees, 52 minutes, what's 72 degrees plus 41 degrees? 113 degrees. So now we need to do 180 degrees minus 113 degrees, 52 minutes. And what would that be? 66 degrees, 8 minutes. 66 degrees, 8 minutes. 66 degrees, 8 minutes. So if you know two of the angles, you'll automatically be able to find that third angle. Now, if you're using, and it's not if you're using an inspired, if you're using an 83 or 84, make sure you group the numerator in parentheses. Make sure you group the denominator in parentheses so you get the right answer. The numerator in parentheses, denominator in parentheses. And we'll round these to the nearest tenth. And for number one, what would be that area to the nearest tenth? .8, and since this is area, this would be centimeters squared for these units. So 5.8 centimeters squared. Do you agree with 5.8? Okay. Number two. Number two, to decide which formula you are going to use, you need to look and see how many sides do they give you. Two. So if you are given two sides, so for two sides, we need to use the formula 1/2 B times C times sine of angle A. But what two sides were we given? A and C? So we need to use this one right here. K equals 1/2 A times C times the sine of angle B. So this would be 1/2. What do I put for A? 7. What do I put for C? 5.4. Then we have the sine. And for angle B, we put 72 degrees. And we will round to the nearest tenth. 18.0? So 18.0, and the unit for area would be square centimeter. So 18.0 square centimeter. Next one, number 3. To figure out which formula to use, you need to ask yourself, how many sides did they give me? So how many sides did they give us? 3. So if they give you 3 sides, if you're given 3 sides, you have to use this formula with a big square root. So that formula is K equals square root of S times S minus A times S minus B times S minus C. And what does S stand for? The semi-perimeter. So semi-perimeter, we need to find the perimeter and cut it in half. We need half of the perimeter. So if I add these 3 together, what is 6 plus 4.3? And what is 10.3 plus 5.2? 15.5? And we need half of that. So what's half of 15.5? 7.75. So in that formula, everywhere you see an S, you need to substitute in 7.75. So 7.75, 7.75 minus side A, 7.75 minus side B, and 7.75 minus side C, which is 5.2. And just type that whole thing into the calculator. Don't stress about showing a bunch of words. Just put it in the calculator. What's on the screen right now, this is the work I expect to see. So whatever you're typing into the calculator, make sure it's written down on your homework page. And again, we're still going to round to the nearest tenth. 10.9 square inches. 10.9 square inches. Okay, problem number 4. Number 4, the instructions say to find the area of the composite figure. So this figure is composed of what 2 shapes? A triangle and a rectangle. So to find the total area of this composite figure, we need to find the area of the triangle and add the area of the rectangle. So now for that triangle, I'm going to have to figure out which of those 3 formulas am I going to use. So looking at that triangle, how many sides do they give me? 2. So they give you 2 sides. You need to use the formula 1/2 B times C times the sine of angle A. And then we need to add to that the area of the rectangle. And how do we find area of a rectangle? Length times width. So there's the formula version. Now I need to substitute in the values. So bring down to 1/2. B and C, what are the 2 sides of the triangle? 19.7, so you can write it out twice, or write it as 19.7 squared, either way. And we're taking the sine of what angle? 125.6 degrees. So all of that is for the triangle. Now we need to add to that the area of the rectangle, and length times width would be 35 times 10. Now that's your work, and make sure you write that down. And our area is going to be to the nearest 10. 507.8 squared. 507.8. And whatever the units are, it would be squared units. I'll just put unit squared. Any questions on the front? Okay, one more. Number 5. Number 5, did they give us a picture?
Yes.
No. So we'll have to create our own diagram. So number 5, it says that we have a regular pentagon inscribed in a circle whose radius measures 7 centimeters. Find the area of the pentagon. Now, a pentagon has how many sides? 5. And if it's a regular pentagon, what does regular mean?
All the sides are equal?
All the sides are equal length. So when you draw your 5-sided figure, make sure all 5 sides are equal in length as best as you can. There's mine. Now it's inscribed in a circle. Inscribed just means it's inside the circle, and all 5 of those vertices are on the circle. So now I'm going to start at the top edge and draw my circle going through each of these vertices. You get the idea. You get the idea. Okay, now they tell us one other thing. They said that the radius is 7 centimeters. So the radius of a circle goes from the center to the edge, and that would be 7 centimeters. And from the center to the edge, this is also 7 centimeters. Now, what are we trying to find the area of? The pentagon. And right now, I broke up that pentagon into one triangle. But looking at that pentagon, how many triangles does it actually have? 5. So when we're trying to find the area of the pentagon, we need to do 5 times the area of one of those triangles. We have 5 triangles, so we need to do 5 times the area of just one triangle to get the total area for that pentagon. Now, looking at our triangle, how many sides did they give us? 2. So if I have 2 sides, let me go back to those formulas. And if I have 2 sides, I do 1/2 times 7 times 7, but I need an angle. Did they give me an angle? No. But they told me it's inscribed inside what? A circle. We know a circle has how many degrees? 360 degrees. And how many of these angles do we have like that? 5. So what's 360 divided by 5? 72 degrees. So that central angle is 72 degrees. Now we can solve it. So we need to do 5 times 1/2 B times C times sine of angle A. And B and C are both what? 7. You can do it as 7 times 7 or 7 squared. And we found that our angle is 72 degrees. 360 divided by 5. And again, that's your work. Type it in. And what do you get to the nearest 10? What was it? 116.5 centimeters squared. Is that the consensus?
What's that?
We agree.
Oh, yes.
Okay, good. So 116.5 squared centimeters.